Good morning. All right. So we are going to jump back into 10.3 today, finish that up. We'll see if we get into 10.8. We do skip over a lot of chapter 10. Like I said, we only have a few sections to do in chapter 10. So we'll finish up 10.3. If we have time, we'll get into 10.8. That'll just leave us with 10.8 and 10.9. And so the plan right now, just to kind of give you a timeline of what's going on, if you have not already seen, I posted a link to a survey. That is for you to schedule a time to take your final exam sometime next week. So there are times available Monday through Friday, 8 a.m. to 10 p.m. Is like the last cutoff, I think, or 10:30. So the last one would be from 8 p.m. to 10:30 p.m. What's going to happen is once you decide when you want to take your exam, I'm going to set up emails for everybody that have your final exam attached. Those will get sent out at the time that you schedule. You will have 2.5 hours from the time that you receive the email to print out the exam if you want to, or just complete it on notebook paper if you want to. Then you'll have to scan it and upload it all within that 2.5 hour window. Okay, so normally my exam would be a 2-hour exam. So I'm giving you an extra half hour just for if you need to print it, then scan it, then upload it, all that stuff. You have an extra 30 minutes to get all that stuff done. So make sure if you have not already, go into that link, complete survey to tell me when you would like to receive your final exam. And again, it will be a 2.5 hour window, but you'll see that in the survey itself. Remember this semester that there was really no last date to withdraw without receiving a WF. So if you decide not to take the final exam, then you will just receive a W, right? So you'll be withdrawn from the course. It will not count as an F for you. It will just count as a W for you. Please let me know if you're thinking about doing that, just so we can look at your grades and decide if that's really the best option for you. Or if you're just questioning whether or not you want to take the final or not, please do email me and we can talk through that. Because I want to make sure everybody's doing what's in their best interest. I don't want somebody sitting for the final exam that really has no chance of passing, but I also don't want people deciding not to take the final just because they're afraid that they might not, and then all of a sudden they get a W instead of being able to pass the class. So if you're questioning where you're at in the class and that kind of thing, let me know, and we'll talk through that. The last thing I wanted to mention is that test 5 has also been posted. You have until Friday at midnight to get that done. We're already through most of 10.3, so you've got a lot of what you need to do that. It's only like the last 2 questions, I think, that we haven't covered yet. So if you want to go ahead and get a start on that, that'd be great. But it will be due Friday by midnight. And I think that's it. I did also cancel the last homework. So there is no more homework after the one that's due tonight. So just the 10.1 to 10.3 stuff. The 10.8 and 10.9, there is no homework because I'd rather you be focused on getting the test completed. Okay, so last homework due tonight, last test due on Friday. Please schedule a time for your final exam next week, and that's all we've got. Okay, so next week there will be no class meetings. I'm going to try to get some review at the end of this week, but next week will all just be final exam days. So I'm not going to try to teach any classes because I'm going to be busy trying to get people stuff scheduled and make sure everybody's got their exams and all that good stuff. So that's all I'm going to be doing next week. Any questions right now? Because I know that was a lot of information. And again, if you do have any questions or any concerns or anything, please reach out to me. Let me know because again, we've only got about a week left of class meetings. Practice tests for the final. Yes. So I'll open up. I forgot to do that. Thank you. I'll get that opened up this afternoon. And again, we will take hopefully 2 days is my goal because I think we can finish up all of chapter 10 by Wednesday. That'll leave us Thursday, Friday to kind of go through some practice questions on that final. But there is a practice. It's just know when I open it up, it's 30 questions, I think, or 33 or something like that. There won't be that many on the actual final. The final exam is 10 questions, okay, so it's reasonable for 2 hours, but it'll be 10 questions that are kind of pulled from those types of questions that are on the practice. Okay, so the practice has pretty much anything you could possibly see, and then I'll narrow it down to 10 of those types of questions for the actual final. Any other questions? All right. So let's jump back into 10.3 then. So what I want to do is let's look at example 4 here because I want to kind of remind ourselves what we were doing last week. We're going to use our matrix shortcut for this one. So can somebody remind me what would be the first thing we would want to do if we want to solve this linear system of linear equations using matrices? What would be our first step? Okay, good. So we need to know how many columns and rows we need, right? So we're going to create a matrix here. So how many rows do we have on? Okay, so we're going to need 3 rows because we have 1 row for each equation, and then we're going to need 4 columns because we know there's going to be 1 for each variable and then another column for all the constants. So now let's talk about what that first row is going to be. What would be my entries in the first row? Okay, so we only include the coefficients and constants, right? Variables, so 4, 8, negative 4, 4. That would be our top row. That represents the first equation. Then when we look at the next one, okay, I'm just going to list these out. So we're going to have 3, 8, 5, and negative 11. And then our final row here is going to be negative 2, 1 for the y, 12, and then negative 7. Okay, and just always, again, keep in mind, if you're missing a variable, just make sure you put a 0 in that place. Okay, so in this case, we have all of our variables for every equation, so we have numbers everywhere. Now, once we do that, if we want to use our calculators to do this, what are we going to do next? Okay, good. So we're going to go to our matrix calculator, right? And it depends on which version of the calculator you have. You're going to go to your matrix menu. Some of you might have to press second and then go to matrix, right? Now, once we're in matrix, then we're going to go to what? Good. Go all the way over to edit. Then we're going to enter our dimensions, which we already said in this case. This is a 3 by 4 matrix. Okay, so just make sure you have 3 by 4 as your dimensions at the top there. Now we can put all the entries in, right? So again, if you just press, in this case, 4, then enter, it's going to automatically jump to the right, and then we can just do that whole first row there. And then you're just going to go through and put every single entry into that matrix. Okay, now once we've got all of our entries into the matrix, then we have to do what? Good. So go ahead and do second quit, right? So that's the mode key right next to the second key. Get back to your home screen. Okay, that's a key step. If you don't do that, it's going to try to put the next stuff into the matrix, and we don't want to do that. So we have to get back to our home screen first. Now that we've done that, now we can go back to our matrix menu. And then from the matrix menu, we're going to choose what now? Okay, good. We're going to go over to math, and we're going to scroll all the way down until we find RREF, which stands for reduced row echelon form. Go to your matrix, go over to math, scroll down to RREF. All right, now once we've selected RREF, then we can do what? Okay, so then we're going to go back to our matrix menu, and in this case, under names, we're going to select the matrix that we put in there. I did mine under number 1, so I'm going to do that. Then we can just press enter, and it should give us a new matrix that is in reduced row echelon form now. So what's that first row this time? Okay, 1, 0, 0, -3. Next row is going to be what? 0, 1, 0. I ended up with a positive 1 there. Okay, good. So it should be positive 1. Oops, sorry. All right, and then the last row this time, what? Good. 0, 0, 1, and then -2. All right, now once we get it into that form, what does that tell us about our solution then? Good. So our x value here is equal to -3. Our y value equals +1, and the z value is -2. And so then how are we going to write our final answer? Order triple, right? Put parentheses around it. That's going to be -3, 1, -2. So that right there is our solution. Any questions about that process for solving a system of linear equations now? Okay. All right. So just so we know, we can still get no solution, one solution, or infinite solutions out of these systems now. And so what we're going to look at next is, well, what does that look like when we try to do it in the calculator? What is that matrix actually going to look like if we have each of these situations, right? So we know what the one solution case looks like. We have, 1, 0, 0, some number, 0, 1, 0, some number, 0, 0, 1, some number, right? And then those numbers in the last column give us our solution. But we're going to look at now, well, what's going to happen to our matrix if we have no solution, right? Because that is a possibility, right? These lines may not ever intersect. Or we could have infinitely many solutions where, these things actually overlap each other, right, in a straight line. And so then we're going to have an infinite number of those solutions. So let's take a look at this one. I'm going to do it the same way, right? We're going to put it into the matrix, put it in the calculator, and then we'll see what happens. All right, so we're going to have another 3 by 4 because, again, we have 3 equations. That's our 3 rows. We're going to have 4 columns because we have the 3 variables plus the constants. I'm going to go ahead and do that. And I'm going to all my coefficients from my first one here. So that's going to be 1, -3, +2, 12. My second row now is going to be 2, -5, +5, and 14. And then finally, we're going to have 1, -2, 3, and 20. All right. That's all right, Sarah. You're a little bit ahead. All right. So now once we've done that, again, we have our 3 by 4. So now we're going to go into our matrix. We're going to enter that matrix under edit. Then we're going to go back to our home screen, second quit, go back into matrix, go over to math, select RREF again. Then we go back to matrix and select the matrix we just put in there. And so do all those steps. I'm going to give you a minute to do that, right? Because I know not everybody's caught up there yet. And then we'll talk about what the entries are in our final answer. All right, so let's go ahead and look at what we get. So what's that first row when we do our reduced row echelon form this time? I think Sarah's already got it there, so that's what she was entering before. So 1, 0, 5, 0 should be that first row. What's the second row this time? A 0, 1, 1, 0. And our last row should be 0, 0, 0, and 1. Okay? Let's think about what that means, right? So let's think about each of these rows individually and think about what those rows actually represent. So what does that first row say? Okay, so we have an X and we have something in the Z, right? And it should be equal to 0, right? So in this case, we have 1X, but we also have 5Z, and that equals 0, right? What that row actually says. What does the next row say? Okay, good. So we have 1Y plus 1Z equals 0. And what does the last row say? 0 equals 1. Okay. Well, based off of that information now, what do you think that means about our solution to this system? There is no solution, right? Whenever you get an equation that says that 0 equals something other than 0, right? In this case, 0 equals 1, that's not a true statement. So automatically here, this one is going to be no solution. Okay. So really what you're looking for there is if you get all these zeros and then some number other than 0 in that last column, okay, that's automatically a no solution now. So we can basically just look at whatever that last row is, okay, and if we have something like that there, that just tells us no solution. Any questions on that one now? All right. So let's look at this one now. All right, so based off what we've got here, we still have 3 rows, we still have 3 variables, so it's still going to be a 3 by 4. Now, if we list out the coefficients and constants from the first equation, we have -3, -5, 36, and 10. In our second row this time, we're going to have -1 for the x. Since there is no y, don't forget we need a 0 in that column. Then we have 7 and 5. And then our last row here is going to be 1, 1, -10, and -4. We're still going to go through that same process, find your reduced row echelon form. I'll give you a minute to do all that, and then we'll talk about what we get. All right, so can somebody tell me what they got for the first row here? Okay, so 1, 0, -7, 5. All right, I think I got a -5 there. Not that it really matters, okay, but I think that was a negative. Okay, what about the second row? Okay, so 0, 1, -3, and 1. Good. And our last row, all zeros. Okay, so that's what we get. So again, let's just think about what this actually tells us then. So we know this first row, we have 1x, we have -7z this time, and that's going to be equal to -5. The next row has the y and z, so 1 minus 3z equals 1. But what does that last row say? Zero equals 0, right? We have no variables, and then it's going to be equal to 0 as our constant. So what does that mean then about our solution this time? Good. This time we're going to have infinitely many solutions. Okay. And if you've been working on the homework, you might have noticed whenever it has infinitely many, it's asking you for a general solution. I'm never going to ask you for that on a test. Those are the only types of questions I could pull from that question bank. So if you get to one that's infinitely many and you're not sure about the general solution part, just send me a message on it and I can tell you what that is. But as long as you can identify it as infinitely many solutions, that's all I'm looking for there. Okay. Any questions on that one now? All right. I'm not going to do a 4-variable one. I do want to do this word problem, though. Okay. All right. So we have a nutritionist is performing an experiment on student volunteers. He wishes to feed one of his subjects a daily diet that consists of a combination of 3 commercial diet foods. Those are called Mini-Cal, Liquifast, and Slim Quick. For the experiment, it's important that the subject consume exactly 500 milligrams of potassium, 75 grams of protein, and 1,150 units of vitamin D every day. Out of these nutrients in 1 ounce of each of the food are given in our table below. So we want to know how many ounces of each food should the subject eat every day to satisfy the nutrient requirements exactly. Okay, so we want to make sure that he's getting exactly the 500 milligrams of potassium, 75 grams of protein, and 1,150 units of vitamin D using some combination of these 3 dietary supplements. Okay. So what we're gonna have to set up a system, okay, using whatever variables we choose here. So what variables do you want to use? Let's define those first. Okay, C, F, and Q, which I assume are C for mini cal, F for liquefast, and Q for slim quick. Okay. And you could have used M, L, and S. You could have used X, Y, and Z. It really doesn't matter, right? So long as you identify what your variables are and then define them. Okay, so now that we know what variables we're using, now let's think about what equations we could start setting up here. So do you see one equation we could set up? And so let's start here. Let's go back to our word problem part, and let's think about what we're given, right? So what values do we know right now? Okay, yeah, right. We have the 500, we have the 75, and we have the 1150, right? So we know we need 500 milligrams of potassium, we need 75 grams of protein, and we need 1,150 units of vitamin D, right? That's the only numerical values that we're even given in this problem. So let's think about how we could use that information now to maybe set up an equation that uses the variable. Sorry, I think I got disconnected there for just a minute. All right, so does anybody have an equation that we could set up based off of that information now? Okay, so the sentence beginning with the amount of these is throwing me off. Okay, so in this case, when we're talking about C, F, and Q, these are actually amounts of mini-cal, amounts of liquefast, and amounts of quick. Okay, so these are actually representing, in this case, ounces, okay, of each one of those things. So that's what we're trying to solve for, is how many ounces of mini-cal, how many ounces of liquefast, and how many ounces of slim quick will give us the potassium, protein, and vitamin D that we actually need now. Does that help, Naomi? Okay. So now let's think about, if we know, let's just focus on potassium real quick. If I know I want to end up with 500 milligrams of potassium, right? Let's think about how much potassium is actually in each one of these things, and what combination of those then would give us the amount of potassium that we need. All right, so I'll go ahead and tell you this one, we're going to need all of our variables because we're using a combination of all three to give us our total daily allowance, right? Okay, good. So Asbel's got it. So it's going to be 50C plus 75F plus 10Q. And we need that total amount of potassium now to give us 500. And so there's going to be our first equation. Okay. Because if I have 50 milligrams of potassium for every ounce of mini-cal, that's 50C, 75 milligrams of potassium for every ounce of Liquifast, there's my 75F, and then 10 milligrams of potassium for every ounce of SlimQuick is 10Q. Putting all of that potassium together now should give me the 500 milligrams total that I need. Any questions on that equation? So now that we've got that, what do you think the next equation is going to look like? Right, okay, so we're going to do 5C plus 10F plus 3Q. And now this represents the amount of protein that I need. So we're going to set that equal to the 75 grams of protein total that I need. And then the last one again, we're just going to do 90C plus 100F plus 50Q. But this time that should be equal to what? Good. So that's going to be the 1,150 units of vitamin D that we need. That should be equal to 1150 now. Okay, so now there's my system. Any questions on how we got any of those equations? All right, so now, once we have the system, we can go back to our matrices, right? So we can put this in a matrix, we can do our reduced row echelon form. I'm gonna let you try that, and then let me know what you get for your C, F, and Q values this time. All right, so Ken's got C equals 5, F equals 2, and Q equals 10. That's what I got also. So what that tells us then is that we're going to have 5 ounces of mini-cal. We're going to have 2 ounces of Liquifast, and then we want to have 10 ounces of SlimQuick. Right, so that would be our solution here, is we would need 5 ounces mini-cal, 2 ounces Liquifast, 10 ounces SlimQuick. That would give us exactly the amount of potassium, protein, and vitamin D that we would need for this experiment now. Any questions on that one? All right, does anybody need more time to get any of that? All right. All right, so now we're going to jump all the way to point 8. And so now we're going to start looking at some systems of non-linear equations. Okay, so everything we've done so far has just either been x plus y equals something, or maybe x plus y plus z equals something, but all that's been x to the first, y to the first, z to the first. And so even in 3 dimensions, the x, y, z gives you a line. Okay, so we've had linear equations through everything that we've done so far. Now we're going to look at, what if we have a system that's not a line, right? What if it's non-linear? And so that's what we're going to focus on in this section. So here's the first one. And I see I have a typo there. I'm trying to remember what the first number is supposed to be. Let me double check that for us. Sorry, so this number right here should be a 10 instead of 100. Okay, the first equation is equal to 100. The second one should be equal to 10. All right, so we want to find all solutions to this system here. And so we can use the same processes that we used with systems of linear equations, but sometimes certain ones aren't going to work. Okay, and so that's why we have to know that, linear equations, we can always use substitution, we can always use elimination, we can always use graphing, and then we can use matrices, obviously, right? In this case, though, matrices are out of the question. We have the squares. We also can't use elimination here because there's no way that I could just multiply by something and eliminate one of these variables, right? And you might be saying, well, I could multiply by y and that would give me y squared. We're not allowed to multiply by variables. We can only multiply by numbers. Okay, and so that's why elimination won't work here. So what's the only real method? I mean, graphing could work here, right, if you really want to graph these. But what would be the only algebraic method that we could use to solve this one? Okay, so you're going to get y by itself in the second equation, right? And then what would you do from there, Kenneth? Okay, good. Then we can substitute the y into the other equation. So that's exactly what we're going to do here. So I'm going to take that second equation. I'm going to solve it for y. So we can move the 3x over. That gives us negative y equals negative 3x plus 10. But then we have to divide every single term by a negative 1 so that we get y equals positive 3x minus 10. Real careful with your signs there, right? So we move the 3x over, then we divide by the negative, and so once we do that, that's what we should end up with for our y. Right, and then like Asbel said, we're going to take that and we're going to substitute it into the first equation now, because remember with substitution, once we solve one, we have to plug it into the other. So that's going to give us x squared plus my y now becomes 3x minus 10. So I have to square that whole thing this time. And that's going to be equal to 100. Any questions up to that point now? All right, so now we're going to have x squared here. What are we going to get when we square the 3x minus 10? we're going to have to use FOIL, right? So we're going to take 3x minus 10 times itself. I'll do that work right up here, because that's what it means to square something. And so if I FOIL this now, 3x and 3x, that's 9x squared. 3x times negative 10 is minus 30x. Negative 10 times 3x is another minus 30x. And negative 10 times 10 would be a positive 100. And now if we combine like terms, should get 9x squared minus 60x plus 100. So that right there is what's going in place of 3x minus 10 squared, plus 9x squared minus 60x plus 100 equals 100. Equals on that step. Okay. Now, combine like terms, right? So we have x squared plus 9x squared. That's going to give us 10x squared minus 60x plus 100 equals 100. What would you do next to solve this? Okay, subtract 100. So basically, we're trying to set this equal to 0 because we have a quadratic equation. So we're subtracting 100 on both sides now. When we do that, we get 10x squared minus 60x. But now the hundreds cancel on both sides, and so this is just equal to 0 now. Then what would you do to solve that equation? Good. Common factor, right? So we have a common factor of 10x, so I'm going to factor that out. And when I do that, I'm left with an x and then a minus 6. And once we have our factors, then we can do what? Good. Set each factor equal to 0. So I'm going to take the 10x, set it equal to 0, and the x minus 6 equals 0. And that'll give me what solutions then? Good. So we get x equals 0 from this first one, x equals positive 6 from the other one. Are we done? Why are we not done yet? Got to find y, right? Okay, so don't forget, right? We've done a lot of work already, but don't just stop there as soon as you get your x's. We still have to go back and find the y. So I'm going to take each of the x values that I found now, and I'm going to have to plug both of those back in to find two separate y values. Let's start with the 0. Where's going to be the easiest place to plug in to find my y now? Yeah, into the second equation, and specifically, we've already taken that second equation and solved it for y. So I'm going to come right back here, and I'm going to plug in that 0 for x to figure out what y is. So I've got y equals 3 times 0 minus 10. What would that give us? Yeah, so y equals negative 10. But I also need to plug in the 6 now and figure out what y value I get for that. So I'm going to get y equals 3 times 6 minus 10, which would give us what? That's going to give us positive 8. Good. So now let's think about what that gives us then. So what's a solution to this system in this case? Okay, so 0, -10, okay, and then 6, 8 would be the other one, right? Yeah, and Naomi, it changed that to a little space with sunglasses. That's funny. But yeah, so it should be 6, 8. It's just because you put the parentheses after it. That's what it looks like. So we get 0, -10, and 6, 8. Okay. Now, let's think about why we end up with two different ordered pairs this time. Why do we have two ordered pairs? Okay, it's not linear, right? Okay, so what would this be? If we graph these two equations here, what would it look like? Okay, close. What type of equation is that equation? It's a circle, right? So remember, our equation of a circle is, x minus h squared plus y minus k squared equals r squared. Or in this case, this just tells us the center's at 0, 0. And so we have x squared plus y squared equals r squared. So that's actually going to be a circle. What about the second equation? Yeah, that one is a line, right? So I'm going to graph this in Desmos just so we can see what it looks like. Show you why we actually end up with two different answers this time. Okay, so there's Desmos. Now I'm going to zoom out here so that we can actually see it. Okay, so there it is. So there's my circle, there's my line. How many points of intersection do we have this time? There's actually two, right? So that's why we end up with two different solutions, is because we actually have 2 points of intersection between that circle and that line. And now if I just come in here to Desmos and I click on those 2 points of intersection, there are the two solutions that we found. So 6, 8 and 0, -10. Those are the two places where that line and circle actually intersect each other. So we don't have the same rules in place that we did right before, because with linear equations, we either had 1 point of intersection, no points of intersection, or they were just the same line and they intersected everywhere, right? Now, because we're going to be looking at nonlinear systems, we could have 2 solutions, we could have 3 solutions, we could have 4 solutions in some cases. It just depends on what the shapes are that we're looking at and how many different times those could intersect, okay? Now, in this case, with a circle and a line, you're either going to have 1 point, okay? They could actually overlap only at a single point on the outside of the circle. You could have no points of intersection, right? The line's just completely outside the circle. You could have 2 points of intersection like this, but we can never have infinitely many solutions with a line and a circle, right? So that's one option that's not even a possibility here. So you're either going to have no points of intersection, 1 point of intersection, or 2 points of intersection if it's a circle and a line. Any questions on that one? All right, so that's where we'll stop. Tomorrow we'll pick up with some more nonlinear systems, right? So we'll actually look at some parabolas and circles and other different combinations of things, and see how many points of intersection we could end up with. But again, homework is due by midnight tonight. That's only 10.1 to 10.3, so you've definitely got everything you need to finish that one up. Tomorrow we'll continue with 10.8, maybe even get to some of 10.9, but again, my goal is to finish that up by Wednesday, and then I'll leave us with Thursday and Friday for review, and then next week you'll take your final exam. Okay, so if you have any questions about anything at all, please reach out to me, because again, this is our last week that we're actually going to meet together, because next week will just be focused on that final. Okay, any questions before we go today? All right. Well, have a good afternoon, and I will see you tomorrow.